Good afternoon, Detroit, and thanks for having us. My name's Matt Wittstock. This is Ian Miller. We are from a team at Lockheed Martin called AI Factory, and we're going to talk just a little bit about AI training to the edge. If you jump forward here. So the AI Factory, as you can see up here, is not actually an 8-bit factory. We are sort of a team that's focused on the end-to-end machine learning lifecycle. So we are doing everything from your data ingest, your data cataloging, versioning, everything in the data side to have clean, reproducible work there. Moving into the training side, deploying models, which we're going to show you a little bit about here today, into actually then maintaining those models, sustaining them, monitoring, retraining, and then a little bit of what you can see here, all of the hardware that underlies all of the work we do for AI Factory. So we're going to see how a little bit of this goes. We brought basically a hackathon along with us. Could go well, could go crazy. We'll find out in time. But if you want to jump forward, Ian.
Yeah, so a lot of the use case around AI Factory is around the concept of MLOps, a reasonably new field, but really it's just taking DevOps principles and bringing in machine learning because the life cycle for machine learning is a little different than DevOps. You have a lot more complexity in your pipelines. Your pipelines might not actually put out the same thing every single time. They're not necessarily completely reproducible. There's inherent stochasticity in the middle of it. So there's a new discipline forming around that called MLOps. And really, like the need from that, from Lockheed Martin or any other company that's employing ML, is the need to be able to trust what you're putting in the field with machine learning, which becomes really challenging to trust once you can't see inside of why the decisions are being made all the time. And so a lot of the machine learning, the MLOps, is around really keeping track of every little step of that pipeline, where your data came from, how was it transformed, how was the model trained, how did that model get to production, how is it performing in production on new data, and really taking into account, how can we trust this thing that is new and we don't really know why it's making decisions the way that it is. There is a field of explainable AI, which is the study of like why a model makes decisions specifically. But what we found is in addition to that, you really just need this robust process to get your models to production, and then you can actually trust based on all these other inputs as well. And of course, all of the stuff I'm describing, it really needs a lot of elasticity and scaling, and GPUs are super expensive, so you might do that in the cloud, but you also might be doing that on-prem, and from Lockheed perspective, we might be doing that in disconnected areas, and so we need something that's flexible to work in all of those different environments, whether you're in a hyperscaling cloud or you're on your bare metal in your server room, and so that's really why we're here. Is we take advantage of a lot of the Kubernetes ecosystem and OpenShift and all of that to accomplish that. Oops. There we go.
Nice. So talking a little bit about the platform and why we are here. So we believe very much in open source first. We use a lot of open source tools. One of the big things that we are all about is making sure we don't go anywhere near a monolith. We're really a lot of small composable modules, pieces of software that we put together into what really makes up AI Factory. That also allows us to really, when we work with different programs and different teams that we have across Lockheed Martin, let them pick the components and needs that they have for their business versus taking some very large piece of software and bringing it all in and getting that through a number of different processes that happen to exist. So we really focus on allowing, it's all open source. We can bring in what we need. We can see how it was built. We then, like I said, modulize it. And of course, everything runs on top of Kubernetes. So of course, platform is a little bit of a loaded term, but I'm going to talk about on this both the platform as in like the software side, but also the platform and where do we actually run this. So a little bit of both. As Ian said, we have to be massively scalable, which means both scale to zero sometimes because the cost is crazy if we're doing anything out inside of a cloud world, to scaling to whatever our need is for a very large data set, very large training jobs that we might have out there. We have to always be changing. So especially in the AI field, new tools come in all the time. There's always new things coming in, so we're always taking a look at what is out there, what is available, what can we bring into our stack that meets a business need for us, and then is there something, maybe a new tool that meets a need we had and we already have something out there and there's a better version of it now. Same thing goes for all of the underlying hardware infrastructure, the Kubernetes layer, of course, all of that is changing consistently too, and we need to be always able to evolve and change with that. As far as where we deploy, we're all over the place. We've got environments that we run out on our public clouds, as well as our government clouds, of course. We have very large central infrastructure. In fact, the one that we tend to use the most is one that we've built. We have an NVIDIA SuperPod that we do the vast majority of our work on, 160 A100 GPUs. That's just one of the many GPU HPC environments that we have. And then, of course, we've got a couple of different things for edge work. So one of them that we use quite often in HPE Edgeline, we'll talk about it more. It's actually where we're running a little bit of our demo. We didn't bring it with us. It's very loud. You wouldn't be able to hear us on stage, but fantastic piece of hardware. And then we do a lot of work on embedded now. So this is where we really brought in MicroShift, moving from a large-scale OpenShift that's running on the rest of our environments to a very light edge Kubernetes that we're running on devices like these right here. So we'll jump into that a little bit more as we go into the demo, so you can jump forward.
Yeah, so let's talk a little bit about what it looks like to deploy your ML model. In this context, we're going to talk about the edge and then the edge, or the embedded edge, and how that kind of process goes. So we have a lot of our training, just because of the resources necessary, you do a lot of your training on your large clusters, like the NVIDIA SuperPod is a great example there, where we have all these GPUs to bring to bear. But then in most cases, your model, at least in the embedded or edge world that we live in, your model is not going to be able to be run on those cloud resources. You need it deployed elsewhere. Maybe it's the Edgeline is like a 4 node server box that you can take with you to places, or even to embedded spaces like the NVIDIA devices here. And so really, we need to be able to move those models that we train to these different environments, and they might be optionally connected or not. And so really, the way that we've been able to make that the smoothest is to kind of standardize our platform layer across those different form factors. And so we're running OpenShift or Kubernetes in the data centers, and also on these edge boxes that we can take to different places with us. And then also now, we're running that on our embedded devices as well. And so because you have that standard stack and that standard underlying platform, it gives you a lot of flexibility to move between those environments, and that's the success we're seeing. So really, we train it in one place and we move it along with us with model registries to these edge locations, and then from there we can provision it onto embedded devices, and that allows us the maximum amount of flexibility for deploying these workloads. Let's talk a little bit about the actual underlying tech stack that we're using for those model serving environments. So really, we lean heavily on a lot of the stuff that we'll see here at Kubecon. I think in the last week or two, there's been announcements for several of these projects even getting donated to the CNCF, which is really cool. But so really, our stack right now is some AI Factory inner source stuff, some Red Hat OpenShift on our large devices, and we have MicroShift now running on our edge devices. A lot of the training and a lot of the AI stuff in the cloud is done with Kubeflow. And then Kserve, which is a project that came out of that we use for model serving both in the cloud. And actually, today we'll be running Kserve on some ARM devices, which I don't know if it's the first time it's been done, but certainly we had to build a lot of it for ARM, so we'll find out. And then Cert Manager and Istio, to complete that stack. So that's generally the tools we're using to do model serving, both in the cloud and we're testing that out on the edge boxes as well. So.
Yeah, so let's actually talk a little bit about an edge use case. In fact, I don't have any links or anything in front of me, but there was quite a bit of press that came out recently. Just this morning, we did fly MicroShift on top of one of our Lockheed Martin Stalkers. MicroShift out in the air, very exciting, running a bunch of containerized AI workloads. Talking about a little bit of the use case for sort of deploying, though, more of this AI, we're going to show off the actual AI inference the way we are. Some of our different use cases often involve a lot of large data collects. So in this case, you can see we've got a little stalker flying, showing a picture of taking a lot of video footage. We collect a lot of this footage, bring it to somewhere centrally, and then we train a bunch of models to better do an understanding of what is actually being seen in that video. and then we deploy that out into the field on these stalkers, and now we're actually getting live inference in this case of what I'm kind of showing here. So this is sort of a computer vision use case. Now, what we really focus on there as well is not only then just deploying that out, very important, but now as you're out there doing inference, you're actually both learning how is this running, is it actually performing very well, and you're capturing a lot of new data. So every time we do some sort of flight, we're capturing a lot of new data, and so then we have all of this to bring back into our central environment with all of this new data we've collected. All of that new data then has to be labeled, stored, cataloged, versioned, slightly out of order there, but all of these different things so we can then take and train the model better again. You know, use all this new data. We might have some new things that we saw out in the field that we're able to train the model on to better understand, deploy it back out again, and continue that loop over and over and over again. So one of the big things, that's where we really focus on all of the pipelines, all of the training, everything that goes involved into making this as seamless as possible so we can just collect data, train, send it back out again, complete that loop. I don't know if there's anything else interesting on that one.
One thing to get into in terms of like, for those that have done embedded or even embedded AI, you might be like, well, why do I need a container orchestration platform in this kind of space? And to be fair, it's only recently really been possible with some of the more compute you can deploy to those embedded devices to run those. But really, if you think about it, you need to be able, or like a lot of our use cases need to be able to change their mission mid-flight, or and that goes on the software side, but it's even greater on the AI side, because you might need to deploy a new model or several models at a moment's notice and be able to swap between them depending on what your mission is or what that end device is doing. And so in dynamic environments like that, the AI needs to be just as dynamic. And what we've already found from running these in these use cases that Matt is talking about is we're able to like have seamless transition of models with no downtime, but switching how the AI is interpreting the data that's coming in, or maybe we can deploy a new capability from the AI perspective, all seamlessly without taking down the asset to go like re-flash it and then send it back up. And so. It's certainly possible to do without the container orchestration, but we find that the container orchestration gives us a lot more flexibility in some of the dynamic environments that these embedded devices would interact with.
So this is leading up to the potentially fun part here. So we'll talk a little bit about the demo that we're going to be doing. I have to decide if I'm going to talk very slowly to preload the demo. So we've got a couple pieces of hardware that we're doing some of this prototyping on and trying to show off here. So back in Denver, we've got one of our edge lines that is running some image generation and I guess a little bit of NLP. I'll let
yeah, it's running two like state-of-the-art models that are open source. So one of them is Whisper, which takes that's from OpenAI. It takes speech to text, and then we have another model called Stable Diffusion. We've pulled that from Hugging Face, another open source model, and I think Stability AI is who trained that one, and that one takes text to image. So really what we're going to do is this mic right here is picking up what we say, and we're going to try to have the AI draw that for us, like draw it, not come up with a search, but it's literally going to create a picture using those awesome open source models, and that's all running on our edge device back in Denver.
And so we'll see how that goes here in just a second when we switch to that tab, because we might be preloading a lot of data. But before we jump there, as I mentioned earlier, these up here, we are running two just NVIDIA AGX, the new ORIN devices, they're dev kits. We've got these running up here with MicroShift on them. We were initially going to run a lot of this demo on there, but switched to just kind of showing how to do a lighter inference on these devices as we go along.
So they'll be running, we'll show, it's running
I'm curious what's on the other tab.
The devices are running K-Serve as well, and then just like a basic canonical AI example called CFAR 10, if anybody's familiar with that. So yeah, okay, so like let's prime this with like maybe like dinosaurs wearing red hats. It is going to be a little bit weird, I think.
Our very first one.
It's hard to see, but the text is like what it's interpreting from what we say. And then the picture will be whatever it is that we're talking about. So we've been talking about tech stuff, so that makes sense. It's a little, to be fair, these models are meant to run in huge data centers, so it takes a little bit of processing time to pick them up. Cats in space.
The only downfall to this model is, as you can tell, the way we built it, the last moment here, it's capturing all the words we say. So that's what's really building this like very large sentence going on here. I love whatever is happening right now.
I think that's a red-headed dinosaur, maybe.
So we like to have fun with this and these kind of things, running it during meetings. So in the middle of meetings, it's generating new pictures as we're talking, which is a massive distractor for the meetings. But boy, is it a lot of fun. A lot of fun.
We'll give it a few more, and then we can turn our attention to the edge boxes in front of us.
We'll see if it generates one more.
There's your cats in space. There we go. Maybe with a live demo, we leave it on that note, you know? And again, we're not taking credit for the models, just the ability to run those on some edge boxes is what we worked there. But yeah, so that's one of them. And then let's take a look at, I gotta drop off the...
Yep.
No gathering is complete without a cats in space.
There you go.
We've got it now. It's taken care of.
All right, so let's jump on one of these boxes here, and I'll talk a little bit. Let's make that a little bit larger.
Huge
A lot
fun.
larger, there we go. Just to give you a sense of what's, oh, that's a little too large, isn't it?
Smaller.
I'll make it all fit on the screen.
Smaller. All right.
So really, this is like what's running on these devices right now. So we have MicroShift running on there. You can see a lot of the control plane nodes. If you can't see, I'll narrate it for you. There's maybe like 6 containers, I think, running the core MicroShift piece of it. And then we have full cert manager running on there and in Istio-D. The reason for that is that's really like a dependency for the type of K-serve deployment that we did. So K-serve is pretty cool. If you haven't checked it out, it basically allows you to, it's like it has some custom resources for deploying models. And so there's a K-serve controller on here, and it will actually interact with Istio for you. It'll interact with Cert Manager, and it'll kind of build you all the stuff you need. So all you have to do is say, here's my model. At the base case, you have to say, here's my model, or my model is deployed out in some S3 bucket. Just go grab it for me. It's a TensorFlow model, and that's what I want to run. And it'll actually go spin that up for you, so pretty cool. So we have all of that control plane running here, and then our data plane one here, which is our CFAR10 predictor. I did make the namespace if somebody can see that, but.
It's good.
And then, let's see, oh man, my preloaded curl is gone. That's fun.
Oh, you are going to hand type a curl.
I don't think so.
Oh, man.
No demo is complete without searching history, right?
There you go.
Found it. And then an example of inference, really like a model at the end of the day is software, right? So really what you're doing is you're deploying it with a REST endpoint. Kserve also supports stuff like a Kafka ingest or for gRPC. But the base case is just deploy a REST endpoint that hits my model with your data that you want to make a prediction about, and then it gives you back the results. So, I mean, at the end of the day, it's literally just like giving some input curl or some input JSON. Oh, it's running on a different IP. Hang on. I preloaded this and everything.
It's probably on the other one.
There we go. So
Nice.
Again, the result is just JSON because it's an endpoint, but you can see we're running the CFAR10 on the ARM boxes. And so really what that entails is, like, I think as we start to see more ARM, both on edge devices, but also in the server room, or I guess your laptop now, thanks to Apple, I think you'll see a lot of these technologies transition to ARM as well. That's an area we see ripe for a lot of improvement for the tooling on top of a lot of this stuff. We had to compile to ARM and build new containers to make it work on these edge devices.
Yesterday
In the lobby at the Westin. Yeah, that's just an example of the same technology that we can run in our data center running on MicroShift right in front of you. So. Yeah, one other thing I'll say, since I think we both talk fast, so we got a little bit of time to vamp here, but one thing I think is ripe in this space is even though we can run these control planes on the edge devices, obviously you're like sacrificing some overhead there for processes that you don't have to have on the device. A lot of these frameworks are built to run in cloud environments. And one place that I think is ripe for innovation is being able to have the control plane running even on the edge line type device, maybe not even in the data center, but be able to manage a bunch of these embedded deployed models that are on these like optionally disconnected environments. So I'm going to put that out there into the world here because I know there's a lot of contributors in the world here, but certainly that's something I see that's ripe for improvement in this environment. You can run those on these devices, but there is only so much overhead. So
that was an out loud feature request.
yeah, feature. I don't know who's working on it. But
Does anyone have any questions? One back there, all right. Oh, the microphone works. Yeah.
Great presentation. How has the platform helped enable collaboration among your data scientists?
Sure, yeah, I'll take that.
I like
So
that.
on most of the collaboration for the data scientists and machine learning engineers happens on our training platforms. And so we deploy multi-tenant Kubeflow on there. And yeah, I think it's just the ability to get an environment that has all of their dependencies and easy access to GPUs has really accelerated their ability to train a bunch of models. And then we also deploy, speaking of other like things that we have deployed in that training environment, we have a number of like distributed training tools. So for instance, Kubeflow comes with one called Katib. The Ray community is awesome and has built some really cool distributed training stuff. And then also Determined AI is another open source tool that we use there. And that allows them, again, like easy access to that, but they can collaborate on building these larger training jobs. And so far they've been sharing our GPU clusters. They're like scarce resources, but so far we've been able to have them share those clusters to pretty good effect. Yeah. But it's really just the ability. What a data scientist or a machine learning engineer needs is like quick, easy access to large scale GPU and distributed training environments. And it's not necessarily easy to build, and so from our perspective, we've built a platform team at Lockheed Martin to deliver that to our array of engineers there. I know that's not the reality for every company to have the resources to do, but it's worked very well for us so far to accomplish that.